Okay. Hello and welcome, everyone. I'm really glad to see so many people here because the parallel track has rich errors. And yeah, thank you for coming here. My name is Dima. I work in Amper team. Before that, I've been leading the Kotlin Multiplatform team for like 4 years. And today I have a talk for you about Amper with a little bit weird name, which I of course forgot to rename or sessionize, so that's a little bit wrong in the schedule. And it's called How We Cook in Amper Kitchen. You will understand what this title means in a few minutes. But let's start. And let's start with a short recap. What Amper is. Because maybe you haven't heard about the project yet, and that's the first time you hear this name. Or maybe you heard something about it, but a lot of stuff changed. And I will be glad to explain and help you to keep up to date with the latest changes in Amper. So what Amper is? Amper is experimental, standalone build tool. It does everything that you would expect normally from a build tool. It configures your build, it manages the dependencies, it downloads them, it caches them, it resolves the dependency version clashes. It invokes compilers and other build tools to build and publish and package your project, and it does the caching of the build and the results and the task avoidance and whatnot. So why I'm making an emphasis on a standalone word here? Because initially, Amper started as a plugin for Gradle. That allowed us to prototype quickly, because we could leverage the power of the Gradle as a build tool and its rich plugin ecosystem and focus on UX, on more experimental things like declarative configuration, like IDE support, and see if they really work, if they click. And so far they click. So we've been working on a complete standalone implementation for quite a while. And now with the latest release, it becomes officially the path forward. And the Amper as a plugin for Gradle will be slowly phased out. Speaking about the capabilities of a build tool, Amper already today can successfully handle real-life cases. It supports server-side with Cater and Spring, and it builds the canonical Spring Pad Clinic or Cater samples. And it also supports KMP already for quite a while. And in fact, the Kotlin Conf app you're using on your phones, this particular version is not built by Amper, but there is a branch on the Kotlin Conf app which entirely built by Amper. You can see the iOS and Android application, and actually the desktop part as well. Actually, I think we migrated the server side as well. But still, like, you might be interested. Okay, that's cool. That's a build tool. It does what you would expect from a build tool. It builds the project. It handles the real cases. So why we need another build tool? And this actually will be a big part of today's talk, why we need another build tool. But to put it very short, in Amper, we would like to focus on user experience by using declarative configuration and a tooling support. And again, it might not sound like a lot or very concrete at the moment. Stay with me for a while. That will be actually like a big part of this talk. And speaking about declarative configuration, as you might have noticed from the screenshots, or maybe you have heard somewhere before, Amper uses YAML as the configuration language. And this is one more choice that we did for early iteration stages, just as using the Gradle as the foundation for our early iterations. And that's still not a final choice. It's still very convenient for us who want to quickly get something done. But we already see quite a lot of input and feedback, both from you, our community, and both from the design of the build tool. So it might be not the final choice. OK, and the question, is that it? Do you know everything about Amper? And you kind of know the main gist of it. But for me, I am definitely biased. I love the project. I'm from the team. So for me, that's not enough. For me, it's just like saying that the Forrest Gump movie is about a man who sits for 2 hours for his bus, and the bus never comes. It's technically the truth, but it doesn't tell the full story. So here, today, using this opportunity, being at the Kotlin Conf, I would like to tell you the full story about Amper. We will move in kind of like the pyramid. We start with the vision. I will try to explain what is the idea behind this project, why the team is inspired by making Amper. Then I will talk about features, but not just like all the like features or like some marketing pitch, I would like to explain why we choose exactly these features to implement and how they help us to build this vision I will be talking about. And finally, I will talk about technology that powers those features. And you will hear some words that you already heard, like declarative or toolability, but we will see how exactly this foundation enables those features that enable this vision. So this will be kind of like a pyramid. And with that, let's start. So let's start with our vision. And here I would like to start a little bit with our background, which actually resonates really, really well with what Keir said at today's keynote, and that was totally unstaged. We did not align it in any means. I haven't seen the keynote until today. Our background in Emperor, we are building Emperor in JetBrains, in a company that brought you IntelliJ and Kotlin. And the inspiration behind those tools was always making our own life as developers better and sharing it with everyone. The Kotlin inspiration was making a language that more fun and allows you to be more creative and focus on what matters in your day-to-day life as a developer. IntelliJ initially was a plugin that renames stuff, because renaming stuff of your project is just boring. It gets into your way of creativity and makes you focus on menial tasks. And this is tools that are created by engineers for engineers that are used by their authors daily. And we in Emperor are heavily inspired by this principle. We also developers, we also interact with the build tooling on a daily basis. And we sometimes get frustrated with that. And we would like to change this. We would like to have ourselves have more fun and enjoyment at our work and also share it with you. So speaking about the vision, we could put in this top triangle fun and productivity. But again, I still feel like it doesn't cut it. I feel like it's not enough, because everyone is for fun and productivity. Show me a product which says, no, I don't want to have my users to have fun. I don't want them to be productive. So I would like to explain it a little bit more. And for that, I will use this concept that is called French fries moment. Anyone have heard about French fries moment? Nice. I'm using some obscure references here. This term has been coined by Laszlo, who was SVP of People Operations at Google from 2006 until 2016. Laszlo coined this term from a sitcom, I think it was 30 blocks, 6 blocks, I forgot the name, sorry. The scene that inspired this term was like this. There are two characters sitting in a dining. They order burgers. The server brings them burger, and one burger is without French fries. The character yells, "Where are my French fries?" To that, server responds, "Well, you never ordered the French fries, you just said that you want a burger." And for that, the character responds, "Well, when you will learn to anticipate what I need, of course I need French fries for a burger." Which is obviously like a silly example, and like the scene puts the character in a not very good light. But I really like this concept because Laszlo saw something powerful in the scene. He saw that in some positions, like for example, people operations, your goal and your missions is to help people. Your goal is to make their life at work more enjoyable. And then the best you can do in this position is to anticipate people's needs, to help them before they even ask. And we are heavily inspired by this principle in Emperor, because actually the tools you use at programming have the same mission. They bound to help you. And the best thing the tool can do, in our opinion, is to anticipate your need, is to help you before you even ask or even maybe know that you need the help here. And Laszlo actually in his book says that this French fries moment is a very powerful moment, but it's also a thankless job. Because when people don't ask for help, then less incentivized to thank you for this help that they received because they never asked. And I think now we will move to features. And the very first feature or like a group of features actually illustrates this principle very well. And it's about avoiding touch and build tool entirely, which is an interesting idea if you think about it. Because usually when you build a product, you want your users to engage with that. For Kotlin, one of the good metrics is how much time you spent in a Kotlin file. For us, the how much time you spent in the build configuration file is anti-metric. We want it to be 0. And we have a couple of specific features that build upon that, but I would like to present one very specific. So this is like a short code from the Kotlin Conf application migrated to Emperor. I cut it a little bit and modified it a little bit. So now there is a red code. Who can guess why the red code is here? Any ideas? Well, in fact, this is a very frequent problem in builds, at least for me. It's because the module that contains this Kotlin Conf application class doesn't have a dependency on another module which contains this init app function. And what Emperor does is if you click the quick fix, there's a short quick fix that adds dependency on that module, which is in fact provided by Emperor, but you don't even know. And if you click it, then your code turns green. That's it. And that's not the rocket science. That's like a small feature. But during this feature, you never actually interacted with the build tool. You didn't know that there is a build tool. Is it Emperor? Is it Gradle? You might not even know if you are a newbie. Like if you just maybe that's your first programming language, then you might not want to know about the build tool. And even if you are a senior programmer, senior engineer who worked with Gradle, with Maven, with Emperor, and I'm sorry for you, then still you might not be up for tinkering with the build tool at the moment because you are in a flow, you are in a creative process of doing your programming with the Kotlin Conf application, not up for a job of tinkering with the build tool. And we are here to help you with the French fries. And actually, you will learn that something happened in the build tool just a little bit later when you look in the build file and you see that actually the dependency block now has this dependency to a shared module. And for us, it's very important because uninterrupted flow always means more fun and productivity. That's, again, something we've been inspired with IntelliJ and with Kotlin heavily, and something that drives us further in Emperor. The next very close group of features, if you think about it, is about fixing errors in a build early and quickly, and actually preventing them as well. Because if you think about it, errors in the build are also part of this flow breakages. So another example. So this is a simple Emperor configuration file. As it says, it's a type of lib, so it's kind of like a shared code, and it compiles for JVM platform, so a single platform module. We have two dependencies, to Kotlin X Coroutines core and to Ktor client. And the Emperor highlights Kotlin X Coroutines core in yellow. Any ideas? What happened here? I will continue my quiz. Versions, yes, I hear someone saying versions. So in fact, if you point your cursor, the Emperor will tell you what's happened. It will say that the declared version of dependency Kotlin X Coroutines core is overridden, and the actual version is 1.9.0. Why is that? Well, because the Ktor client, and the Emperor will show this to you, the Ktor client brings another dependency transitive to the Ktor client JVM, which depends on Kotlin X Coroutines core of a different version. And as any modern build tool in JVM, I think, they all try to avoid having multiple libraries of the same version on a class path, so the Emperor prefers the biggest one, which is 1.9. But your build script is lying at this point. It says it's 1.8. And we would like to notify you about this, because we believe that that's not a very good idea to have a build config that lies to you. So you can obviously click the quick fix and just bump the version. And yeah, having a configuration that reflects the reality means less surprises in the future. It means more reliability. And if you think about it, it's not unique to build tools. Your code, when we write the code, a good code, I don't always write a good code, but when I do, then I usually try to make it so that the code reflects the reality, that it doesn't lie to anyone who reads it. And I need help in that. I need my tools to help me with that, and that's how we came up with these features for Emperor. Next point, like still, even if you have all those errors and warnings by Amper and like these nice quick fixes you can press and do the stuff for you, at some point you have to open the build files and start reading them. Maybe because you need to understand what's going on with the build, maybe because there's some error which we couldn't handle. We're still not in the age of AGI yet. So you have to read the build configuration. What Amper does here is it tries to make it concise and declarative and expressive, which is very, very close to what Kotlin declares as a language again, and you can see some parallels here. So on this slide, you can see a configuration for a shared module of a Kotlin confab. And yeah, I hid a little bit of lines just to fit more on a slide, but actually the 25 line is all the settings, and then like just list of dependency comes. So we have 25 lines for configuring a shared code, a multi-platform module of a Kotlin confab with compose, with partialize, with some Kotlin stuff, and that's it. So, and even if you never read Amper, you might get a good idea what's going on because the things are here, they're expressive. It says that it's a lib. It says that like platforms, Android, JVM, and iOS ARM. It says partialize, compose, Kotlin. It's expressive. At least we're trying to make it so. But I can already see some people making a point. OK, Dima, that's nice. That's a good demo for a Kotlin conf. Like you show in one slide with 25 lines, and that's impressive. But in reality, when something breaks, I don't need this like a lot of implicitness. I know I want explicit stuff. And indeed, that's a trade-off. We actually see this trade-off as kind of like two axes. On one axis, you have this like on a horizontal one, you have like the spectrum from not having any defaults, so everything is super explicit, down to having many defaults when everything is implicit. But on the other axis, on the vertical one, you have the spectrum of how familiar you are with the code. Are you new? Are you like have your caches hot about what's going on? Or you are well familiar with the code, maybe you have written it 5 minutes ago. And the problematic part is that like those two parts. Because when everything is very explicit, but you are familiar with what's going on, then you call it verbosity and boilerplate, and that's fair. And when you are new to the code and everything is very, very implicit and has a lot of these defaults, you call it a black magic, and you're again right. So what we do, how we should choose as a build tool authors that want to design the convenient build tool for you. Because we don't know if you are like a senior build engineer or just a person who sees this project for the first time. And the answer is the tooling. So we have this CLI command, which we probably should put in the ID, that is called Amper show settings. If you code, it will bring a huge report, which is actually all of the settings that are applied at the current module. It's a valid YAML. And it doesn't fit in the slide, it's a lot of lines there. But I would like to guide you through a few highlights and show how to read that. So the very first thing you will see there is something like this. It will say you that this, for the final config, the Android namespace is set to org JetBrains Kotlin conf. Well, that's fair. We wrote it here. But also, it will add this comment. This is a YAML comment, again, because this is the valid YAML. You can copy-paste it back to file. And it says that this setting came from module YAML file of a module shared, which is exactly where we declared that. OK, that's nice, but not super convenient, not super impressive, because this is exactly, we already can see that the namespace is declared in this file. But what is more interesting is now, like, for example, this. The compiler SDK is not declared in the file, but the Amper show setting will say that it is set to 35, and it will say that it's a default applied by Amper. Moreover, you don't see application ID in a configuration, but obviously you need application ID. Where it comes from? Can it be a default? No, it cannot, because how Amper knows that application ID should be org JetBrains Kotlin conf? It's a very specific string. So in fact, it inherits it from a namespace property, and the show settings will tell you again that this application ID is inherited from a namespace property declared in YAML of a module shared. And finally, this like min SDK is also an important property, and it's actually not a default. In fact, it comes from this. We haven't talked about templates yet, but in fact, templates are very simple things. It's basically the same files in module YAML, and you can apply them by using this apply, and then it just applies all the shared build configuration in your build. That's it. So the show settings tracks this as well. And this, again, reflects what, this is not a very complicated feature, but it shows our values. It shows our principle, how we build Emperor, that we need to show up when you need us. But if you don't need us, if everything is clear and convenient for you and you're fine, then we don't get in your way. And the last bucket of features that I would like to highlight here is fluid config editing. Because again, no matter how readable it is, no matter how many quick fixes we have and refactorings have for you, you'll still someday need to open the build file and start typing. And again, we want to make this interaction as quick for you as possible. So the one thing we do, and that's not even I cannot really call it a feature, because having a completion is a baseline nowadays. I don't even think it was mentioned, but it is here in Emperor. You have a completion. But what is more interesting is that Emperor has this hierarchical structure of a DSL, any kind of a DSL nested structure. And sometimes you forget about at which level you need to start typing stuff. Emperor supports that. So as you can see here, the Android is the proper nested block under the settings where you need starting compile SDK, but you forgot about this. Or maybe you didn't forget, maybe you know that perfectly, you just don't want to spend your time typing Android and hitting enter and then typing compile SDK. Totally legit. We understand you. I also don't have a lot of fun in doing that. So instead, we in Emperor provide this nested completion. And if you hit this, then it completes all the levels and puts the cursor and then provides more completion, obviously. Moreover, I have one story to share with you. So I've been doing Kotlin Multiplatform for 4 years, 5 years. Most of that time, I've been doing Gradle. And by this day, I still cannot remember how to change the GDK version JVM target of my compiled bytecode. And fair enough, there have been some problems between Gradle and KGP. I actually participated in a couple of those problems. I'm sorry, folks. But nowadays, it's much better. But I still cannot remember. Something is broken in my brain, I guess. So what we do in Emperor is we provide kind of a smarter aliased completion. We don't require you to remember if that was JVM release, JVM target. We just put a bunch of words here. So if you type GDK, we will try to do the best guess possible for you and provide the completion. Again, all of that is because we believe you have better things to do than doing with this mini build configuration. Then typing stuff, then remember if that's a JVM or GDK. You have more important business to attend. And yeah, so that concludes a couple of the feature buckets. And you can see how all of them aimed at minimizing your interaction with the build tool. And because we don't feel that this is the time that is well spent in your day-to-day work. Now let's talk a little bit about technology, about what makes these features possible. The very first one I would like to talk about is a tight integration with compiler and IDE. And again, this is sort of obvious idea because we're building Emperor inside JetBrains. We're also building IDEs. We're also building a Kotlin language. So it's obvious that we do the tight integration. But I would like to make it a little bit more specific. The tight integration here doesn't just mean that we call functions from IDE. Everyone can do that. Tight integration here means that we optimize around being a toolable build tool, sorry for the pun, and we optimize around the build tool for Kotlin. One of the examples is this. So this is a valid, again, Emperor configuration, and you can see this @JVM suffix. And again, you might not know Emperor, but you might guess that this is something that deals with multi-platform configuration. This dependencies block is a common dependencies for all of the compilation targets of your module, and this JVM is a JVM-specific dependencies, like a Guava, which is a single platform, I guess, two-platform Android and JVM library. And this is it looks like a very small, nice feature, like just add JVM to the YAML block called dependencies. Is it? Well, in fact, this is the internal design documentation about everything that follows from us having these add symbols. It's still going. So this is a big feature. It expands a lot of design budget. It costs us a lot in the complexity. But we are still willing to go for this. We're still willing to maintain and add this feature because we know that it makes the life of Kotlin users better, and we're ready to pay a big price for that. But the next part about how we deliver those features is actually like the biggest one. I intentionally made the foundation blocks uneven. It's a doable and predictable build behavior. What that means? Let's talk a little bit about that because, again, it's a lot of some abstract words. And for that, let's look under the hood of Emperor. Let's look how it works, how it delivers all those diagnostics and the quick fixes. And let's take as an example the diagnostic we have seen before about the mismatched version between Kotlin X coroutine score and Cater. And let's make it actually even a little bit more complicated. Let's extract the Cater client declaration dependency to a template and apply this template in the current module, and the warning will be still shown. And we'll use this example as a demonstration. So for starters, let's understand what's going on here, like what has happened here, how this clash happened. And I will use a little bit of a shorter notation because I need to fit a lot on this slide. So we have a template with the dependency of Cater dependency, and we have a module YAML which applies this template and has coroutines dependency. So what Emperor does first, it applies the template, which simplistically speaking means that it copies whatever was in the template in a module file. So now in dependencies block, we have coroutines and Cater. Then it does something that is known as transitive dependency resolution. It goes to Maven, or maybe to your Maven local or like local Emperor dependency cache, and figures out that actually Cater depends on the coroutines of version 1.9. I omitted the Cater JVM again for the sake of the example. And finally, what happens is something that is known as a version clash resolution. Again, as I have mentioned before, the build tools try to preserve it so that you have only one version of a library on your class path. So it will try to choose one. And how Emperor does that, it uses the highest win strategy. So the coroutines of version 1.8 will be just thrown out. So that's what actually happened. But now let's see what Emperor does to make it explainable to us as the users, because this is like a pretty complicated process and I simplified it quite a bit. In fact, what Emperor has under the hood is something we call traceability. It's an ability to basically know what's going on in your build, if put like very, very vaguely and generically. But in fact, it knows about all the transformation of values in your build, where they come from, and how they ended up where they are. So in this example, when it applies, the Emperor applies template, it knows the Cater comes specifically from the template file. It knows the coroutines comes exactly from module YAML file. When it resolves transitive dependencies, it knows that the second coroutines version of version 1.9 came exactly from Cater, which came from a template file. And all those traces are preserved. And this is something we build in a very, very core of Emperor from basically day one. So by the end, when Emperor sees the coroutines of version 1.8 has been thrown out because of dependency clash version resolution, it traces all those connections back from the coroutines 1.8 to here where the transitive dependency result, to here where the template has been applied, and back to source file where it reports the warning exactly on the range of this coroutines version. Not just in a log, because that would not be very useful. And this feature traceability, it allows us a lot. It basically provides Emperor with a deep insight about what's going on in your build. And that's what powers these useful assistants and all those like interesting and cool features I have shown you before. But the question is, like, does it come at no cost? Is it something that's like easy to do? And the answer is obviously no. As always in engineering, it's all about trade-offs. So what harms traceability? Let's talk a little bit about it. For example, something like this harms traceability. You have if that goes to your environment variable, environment with some environment variable, and add two dependencies. Probably you could make an argument that like Amper in this case could have like reverse engineered stuff and like say, hey, if the dependency is Kotlin SQL score 1.8, then probably the property has been true. But if you just build a more complicated example, it still all falls out. Actually, speaking about more complicated examples, something like this harms traceability. You have some collection, you go filter with some your arbitrary imperative predicate, you do fold because fold is cool. Like you can, I just learned yesterday that you can express everything with fold, so let me use that. And then in the end, it turns that actually that's the dependencies of our build. Where they came from, how they came, what happens. It's very hard for the tooling to understand that in order to provide those like warnings and a quick fix and diagnostics. And maybe some of you like now say, hey, Dima, yeah, I know what you're talking about. You're talking about declarative configuration. And yes, that's indeed a very important foundational part of being toolable. But I want to emphasize that it's a little bit more nuanced. Declarative is not always traceable. Let me show you an example. This is Maven. It applies a plugin. Yeah, I think the indentation broken, but yeah. So that's a Maven that applies a plugin. And the plugin is called My Favorite Conventions. What happened in the build? Which conventions has been applied? How the build tooling or ID should diagnose the problems of your build. Maybe your favorite conventions are dependencies. Maybe it's a compiler arguments. Maybe you put the list of modules by this plugin. Or maybe you have even more crazy stuff. And also, vice versa. Is it true that imperative is always untraceable? And again, the answer is no. Let me show you an example, and that's a totally imaginary syntax that has nothing to do with like what we would like to have in Amper, but just for demonstrating the point. Actually, some of the languages, some of the declarative languages like Pico have something like this. I didn't want to bring them on a slide to not like confuse everyone. So in totally imaginary syntax, we have kind of like an imperative insert in a declarative language. Like a product platforms filter, it doesn't equal JVM, it doesn't equal Android. That's a very imperative code. But in fact, with this imperative code, we know the final value. It's iOS ARM64 and iOS Emulator ARM64. We know the inputs. That's the product platforms right here. And we know the transformation. That's exactly this filter declared in this file and this line and column number. So what it actually means to be toolable and traceable. And definitely declarative configuration, again, is a big part of that, but that's not all. What you also need is you need a clear, well-tracked inputs for your build, and you need the predictable transformations of those inputs to the final values. And that's something that Amper started with. If you open the Amper today, that's what you have. We have a declarative configuration. All the inputs for the build are very tightly mandated and regulated by Amper, and all the transformations are predictable because they are built into Amper. Yes, we know how to predict our own transformations, which is not always a given, yes. But there's a fine and an ointment here, because there's a real life. And you cannot do everything with declarative configuration, because the actual build work of writing files on a disk is imperative code. Because stuff like environment variables is important for real builds. You're using that, for example, to express differences between local and CI environment. And the transformations cannot be like controlled, all of them, because we cannot expect everyone to rebuild the whole build ecosystem from scratch. We need something like plugins for that. And that's where the Amper today sits at, between this trade-off of like being a really nice and toolable and some real-life cases. And this is a really good place to move in the last part of this talk, which is talking about the future and how Amper as a project wants to resolve this contradiction. As you already seen, the toolability and extensibility, they're not like directly oppose each other, but it's much easier to make a very toolable build if you don't care about extensibility and you are very restrictive. And it's also easy to be super extensible if you don't care about toolability. We actually can put a couple of the build tools here, like the Maven is decently extensible, decently toolable. The Gradle is much more extensible than Maven. I guess a little bit less toolable because of the imperative code and the build configs, which the folks are addressing now with the Declarative Gradle. And you can even make even more examples, like CMake is super extensible. It doesn't restrict you into a lot of stuff, much less than Gradle does, or Maven, but it's even less toolable, obviously. So Emperor here, somewhere here, like the Emperor of today, the 0.7, which actually was released yesterday, is somewhere here. Quite toolable, more toolable than a lot of other alternatives we have, but less extensible, more restrictive. And we can see that, how it harms the real scenarios. So what we would like to have in future with Emperor is move somewhere upwards. We want to have an Emperor, potentially 0.8, which has something that helps you with the plugins and the custom tasks. And actually, that was one of the big internal researches we had in the team. One of the big risk factors for the projects. Can we move it up and right somewhere here? Because, again, it's easy to move it up and left. But that's not what we want, because you have seen how this traceability and toolability in the foundation brings the features that brings the core value of the project that the team wants to make. And I'm really glad to say here that we see that it is possible. Where the team has been doing a lot of the research in the last half year. We've been looking into a lot of real-life plugins from the Maven and Gradle, like the Spring Boot plugin, like the KT-lint, like the cover, the protobuf generation, all of the stuff. And we can see that, yes, it is possible to cover the core scenario, to provide the API so that the plugins that cover the core functionality are possible, but we are still not losing the toolability. That's why the next milestone for Emperor, which is probably 0.8, but please don't quote me at that, like as usual, no promises at KotlinConf. It's something that we want to ship with the preview of our extensibility API and show what you can do now with Emperor without losing the toolability. And speaking about more general direction, somewhere up here in the top right corner, probably, potentially, exists ideal build tool. IBT, nice abbreviation, use it. Does it exist or not? I actually don't know. It might not exist. But we want to move here. We want to push it. We want to move more upwards and be less restrictive and more extensible to cover your real scenarios and also improve the toolability further. And on this path, we need your feedback. We are an experimental project, and as any experimental project, we are living by feedback, no matter which one. Is it a negative feedback? Amazing. Positive feedback? Even better. We need to know what you do with this, because the worst thing that can happen with the experimental project is not having any feedback. So please try Emperor. This QR code leads you to a kind of like a getting started tutorial about Emperor in our docs repository and show your feedback. Join the Emperor channel on the Kotlin Lang Slack, report your issues, ideas, request for more features, for more diagnostics, for anything you would like to see in a build tool to make it more enjoyable for you in our UTrack, issue tracker. And yeah, talk with us here at the KotlinConf at booth, find me here. And yeah, let's have a nice Kotlin. Thank you.